Welcome to another edition of Community Office Hours. As always, my name is Tim Twick, and I'm here with Sam Snyder. And we're going to take you through everything that is new with OpenRewrite this week. And then we're going to go a bit more in depth on how scanning recipes operate. So, yeah, let's go see what is new this week. For that, I've got a couple of tabs, and I'll show the links in the chat as well. So first up, we put up a new video on using Codemods for JavaScript together with Moderne. So if you're the type to prefer a video format, then we have this video. We're also working on a blog, which will go in more depth here as well. But it's basically what we showed you last week, that you can now use the Moderne platform to run JavaScript Codemods. Where last week we had some 300 recipes, we're now up to 437, so we're just adding them up quite quickly here. And we're curating this list such that you get any code mods that you might not have known about that are, we think, worthwhile running against your organization. And then through the platform, you can run those at scale. So we have some cleanup recipes to go in here, and you'll see familiar technologies show up. And the same when we look at modernization recipes. You also will notice recipes for Angular this week and all of that. So pretty neat, and very cool that this this effort has pushed us over the 2,000 recipe mark. So I started presenting on OpenRewrite. I think we're in the 700 recipes. That's 2 years ago, and we've threefold increased by now. So pretty cool. And then apart from this, we also have some new recipes from friends of ours at Picnic, who have an error-prone support open source project on GitHub, and you can find it there. And what we've done is we take a subset of the, I think, 800 something Refaster rules that they have, and we make those available through the platform as well. So if you go to Moderne, you can now browse some 329 additional recipes here. And this also covers some recipes that we didn't have before. So if you want to migrate from TestNG to Azure J, then we allow you to do that now through this leveraging an existing tool and running that through the platform. And there's some really neat things in here. It's like the list is long. I won't call out everything. But you can see that quite quickly there is something that will likely help improve your projects. And we've been running them against our own software already, and we saw some nice improvements, especially for the time rules recipes that are just really worthwhile running as well. So really neat, and go have a look and let us know what you can find there. So next up, on the more manual side of recipes, we had a community contribution for recipes to help you migrate away from Swagger.
Tim, could you zoom in your web browser a little bit? That's maybe a little hard for people to read. Thank you.
So this is recipes that will together allow you to move away from Swagger towards springdoc. And the way they do that is we first upgrade your Swagger implementation. So if you want to stay on Swagger, that's an option as well. And then we allow you to switch to springdoc. And then when you do that, we also allow you to upgrade springdoc. So no matter what you're using, there's something in here that will help you modernize your application. And it's a frequent request that we saw in the community chat, where folks are migrating from older Spring Boot versions to the latest, and then finding that this needs to change as well. So we have support here. It's also in the OpenRewrite modules, so you can use it from there. So really need to have this addition. And again, the community shines when we see these contributions coming. So really neat. As part of that, we also did a larger complete release of OpenRewrite, and you can find the details on there. This link, which I'll share in the chat. And you'll see this includes the Open API module that is new. And we also have some very nice additions. So one thing is that we are now able to bump transitive dependencies for Gradle. So in the past, if you had create all your manage your dependencies, and you maybe have a vulnerability in a transitive dependency. We couldn't yet help you out there. But now that we have this mechanism of introducing constraints, we can actually make it such that you are able to adopt a newer version of a transitive dependency in the regular format of doing that for Gradle, such that you can get those fixes in. So that's really cool. And that will that's immediately available for all the recipes that we have. So really neat addition there. Another part of that, we had some community contributions, one in particular for Hibernate, which is really neat. We have 7 or 8 pull requests open from our friends at IBM, who are helping folks migrate away from OpenJPA to Eclipse links. So that's really neat as well. And you'll see those come in over the next couple of days as well. And here you see the various Swagger recipes that came in. Some of them had some changes, which you might run into if you build upon these recipes, but the replacements are really easy and documented here as well. So have a look through, and you should be able to use all these new versions. And on the releases page, you can see how they all work together. And we have a particular page for our recipe-bom, which lists all the various plugin versions that work well with this new release. So use the recipe-bom with this release of OpenRewrite and these related versions of the plugins, and you should be good. And we list all of those compatible versions on our docs as well. So have a look, adopt that, and let us know if you have any new feedback to share. Then on the blogging side, we have an update to a very popular blog, which is the upgrade to Spring Boot 3 originally. And it now tells you the steps to take if you want to upgrade to Spring Boot 3.2, which is the latest stable release. And then what we've done here is refresh it a bit, update the links to the recipes. And we also added a small section on not just upgrading to Java 17, but now also moving you towards Java 21 and virtual threads. So if you want to know how to do that migration, you can read it in full here. And then last week, I already shared the blog that we had on our own migration towards Spring Boot 3.2 and Java 21. So if you want to have a read, then go look at that. With that, I think that's everything that is new this week. I'm not sure if you have anything to add, Sam.
No, I think you covered it pretty well.
Okay, perfect. Then I'm gonna give it over to you, and we can look more in depth towards scanning recipes.
Yeah, absolutely. So in past sessions, we've talked about various aspects of recipe authoring, your recipe authoring fundamentals, your usage of Java template. And today we are going to discuss a slightly more advanced topic in recipe authoring, and that is the scanning recipe. The typical interface that is provided when you override just the regular recipe class is that you return a visitor from that getVisitor method, and that visitor method is then applied by OpenRewrite's recipe execution infrastructure to each source file one at a time as it goes through all of the LSTs that were parsed from your repository. And that's great and good for most transformations. But every now and then you might have a problem where you can't make all of your decisions about what to edit or to record into a data table when looking only at an individual file. You might need to consider the broader context of the project in order to make a decision, or reference multiple files before deciding whether to make an edit, or maybe you need to check if a file already exists in the project so you know whether or not to create that file fresh or to edit the existing version of the file. And so whenever you are in a situation where you need to consider more than one file at a time, it's a scanning recipe you're going to need rather than a regular recipe. So today we're going to author a basic scanning recipe, and if there's time, we'll talk about composing scanning recipes together, as it's a bit more awkward to do that than it is with regular recipes. So maybe we'll go ahead and start sharing. And there we go. So now I'm just sharing our rewrite recipe starter. And we're going to create, and for this example of a scanning recipe, we'll go with one of the most basic ones, which is, what do they call this? Create new text file. Let's call this like append to readme. So this recipe will be one that will append a line of text to a readme.md file if such a file already exists in the repository, or it will create the file fresh with that text if it doesn't. And so since just that check, does the file already exist or not, requires you to consider, not just the files that are already in the project. We need to make a scanning recipe for it. So we're going to extend scanning recipe. And note, unlike the regular recipe, this guy takes a type parameter, static, or actually we're going to make this a public static class. And we'll fill in some values in there later. And this is going
feedback if you can increase the font just a bit.
How's that?
Yep, cheers.
So now let's have IntelliJ implement the methods. And we see a few of the ones we're familiar with from implementing a recipe, like display name and description, which we can go ahead and fill those out. Or create that file if it does not already exist. Cool. And so the methods that it populated as required because we're extending scanning recipe, we'll go ahead and add our Lombok annotations. Here are about getting an initial value, getting a scanner, an optional generate step, which is not required, but we will be taking advantage of. And finally, the get visitor method is still there, but instead of overriding the form of get visitor that takes no arguments, we're going to be scanning recipe overrides the form of get visitor, which accepts the accumulator type specified in this type parameter. And so the life cycle for these guys is, maybe I'll just move this up to the top, just that's how I like to have it. The life cycle for a scanning recipe is a little bit different than that of a basic recipe. A basic recipe participates only in the edit phase of OpenRewrite recipe execution, where which is that step where each LST in the project is passed through one at a time, and the visitor is applied to each LST in turn, or at least applied to each LST it is applicable to. A scanning recipe gets to participate into earlier phases of the recipe execution lifecycle, and that is the scanning phase and the generation phase. And the scanning phase is a lot like the edit phase in that every file in the project is passed through once and a visitor is applied to it, but it differs from the edit phase in one crucial way, and that is edits are not allowed. Any changes made by the visitors returned from these get scanner methods are just discarded. They're not applied, they're not kept. So the only purpose of applying these scanning visitors is to save information into this accumulator class, which, as you've noticed, is something that each scanning recipe defines for itself, a custom data structure, which can hold whatever information it might be interested in. And then that information collected in the scanning phase is passed through to the generate phase, which is an opportunity to create new files. So if you want a recipe that is going to create a file that does not already exist in the project, you need a scanning recipe, and the generate step needs to return a list of the new source files it is creating. And then finally, the edit phase happens basically the same as in a regular non-scanning recipe, but you have the advantage of all the information that you may have collected in earlier phases to reference. So let's go ahead and start filling this out. First thing we need to do is maybe add a field, a Boolean exists field to our accumulator so that we can check during the scanning phase whether a readme.md file already exists. And we could, just use an atomic Boolean up here instead of defining this inner class. That's totally fine. Like if you want to use some pre-existing data type, like a list of strings or whatever, you totally can. I have tended to find that during recipe development, as you add new features and options to recipes, you will just tend to add more things to this accumulator class. So I usually jump right to defining a custom data structure, understanding that as I work on the recipe more, it will grow to include more fields, even if it starts off simple. So for get initial value, we just need to return an instance of the accumulator type, which is simple enough. And so now in the scanning phase, what we're going to be looking for this particular recipe is whether there's already a file with the path readme.md. So I'm going to return a new tree visitor, and I'm going to override its visit method. And since the very first element that in any given file that's going to be visited is going to be a source file implementation, I can safely just directly cast this tree to source file, which we need to do if we want to check at the path. But I will, out of an abundance of caution, I suppose, do an early return. Yeah. So I like to do this early return style where I reject it. If it isn't what we want. And so what I'm going to say is this, thanks GitHub Copilot for suggesting this text to me, but it wasn't quite right since I want to kind of or equals. And I don't want to resolve. Yeah, so GitHub Copilot almost got this right. What I want to say is git copilot dot. Let's say we don't need to check if it exists. Now, so this would just say if there was any file throughout the project that ended with readme.md, which is maybe fine. Maybe we'd want this constrained to just the root directory. But that's let's say that's good enough for now. Cool. So now we've recorded in the scanning phase whether or not there is a file that ends with readme.md. So if there isn't one, let's go ahead and create it in the generate phase. So, and the implementation of super.generate is just returns an empty list. So say empty list. So I'm going to look at if it already exists, then we'll return an empty list. Otherwise, we need to return a new source file for this, and we don't have an LST type specific for Markdown, so I'm just going to use plain text. So I will use a plain text parser and return that. So plain text parser builder build parse, and we'll just have it parse the empty string, and we'll return a list of that. Cool. So, and one thing we want to be sure to do for any new file you create, if you use one of these parse methods that just accepts a string, some essentially random file name is chosen for you, just a sequence of numbers. The exact behavior there may differ based upon the parser, but you will always want to be sure you set the path here if you care what that path is, and most of the time you would, unless we were talking about some kind of temporary file. So I'm just going to say map. I'll say cool. So is this cast even necessary? Okay, yeah, it does want that cast. Okay, so now we have parsed an empty string into a plain text source file and told it, that the path on this guy will be readme.md. Obviously, if you're parsing multiple source files here, you wouldn't want to map them all to have the same path, but since we're clearly just parsing one, that's fine. So now we'll have created a readme.md if it does not already exist. And so we'll be going into the edit phase knowing that there is a file in here somewhere with the name readme.md. Oh yeah, I should add an option to this guy so that we can specify the message we want to add. Option. Yeah, very good. Thanks, Copilot. This is a pretty good display name and description for this field. Looks good. Yep, cool. So now in this edit phase, we will know that that if the file did not already exist, it has been created. So now we need to find it. So we'll use a plain text visitor here. And we'll visit the plain text file, and we'll repeat kind of our check from up here. So, well, I guess text always implements source file, so that's not necessary. So what I guess I want to say is if text get source path ends with so if we're looking at any text file other than readme.md, we will return early. And kind of similarly, if the text already contains the message we're interested in, well, then this is already run. What are you complaining about here? Oh yeah. If it contains the message, then we want to return early and make no changes. And then if it doesn't, then we'll want to return text with text, text get text, plus we'll add a new line between them and put that message in there. Cool. So now we have gone through every stage of the scanning recipe lifecycle. We have checked whether a file named readme.md exists. We have generated one if it does not. And in the end, we have edited it to add the message if it wasn't already there. So let's make a test and exercise this guy a bit. Pin to readme test. Zoom this in. Implement this rewrite test. And there aren't really any major differences in how you test a scanning recipe from a non-scanning recipe in terms of how it's set up. So it's broadly the same, although I guess we may use a couple methods you might not have seen before. So let's see, we'll configure our recipe and we'll make a test for when the file doesn't already exist and one for where the file does already exist. Void does not. Rewrite run and assertions. Oh yeah, it's like source specs.text. I'm going to add a static import for this. Okay, so to make an assertion about the creation, or to make an assertion that a recipe creates a file, the way you do that is you set the before text in this function to null, and then we say in the end that we should produce this string. And that is well and good. And we need to tell it that this has a particular path. So let's run this and see if I live coded all of this right on the first try or not. Oh, yeah. Recipe validation helpfully reminds me that recipe descriptions should end in a period. Fair enough. Cool. And the test passes. So I did remember how to do everything right, but let's for a moment see what it would look like if I didn't set the path here, just like what the error message you would get, so that if you do forget this step, you will recognize the error message and know how to handle it. Oh, that was surprising. I would have expected it to complain about it not having a particular path. That's interesting. That'll have to be something that I look into later. I feel like it used to fail there if you produced a file that didn't have it. Maybe let's also take a look at this. If I skip the step where I set the path of the new file, what the test framework should tell me that, hey, this file was created, but I didn't know about it. Yeah, okay. So for one, it broke the recipe in such a way that it created multiple files. So we got a complaint about the recipe expecting to complete in one cycle, but it took 2 cycles. So yeah, these are some of the kinds of errors you can get if you don't have the file paths all matching up in a recipe where you are creating new files with the scanning recipe. Okay, so now let's also cover the case where the file does already exist. And I'll just copy that to start. And so we're expecting that this is what the recipe should produce when the file already exists. So let's see that it does. Yes, and this is also handled correctly. So that's an example of a basic scanning recipe that can handle both a file existing and not already existing in order to achieve some specific effect. Now, there are a lot of quite a few places where scanning recipes are used, and so if you ever want to find examples of scanning recipes, you can use this find implementations method, or this find implementations recipe, searching for scanning recipe on the OpenRewrite organization, in the app.moderne.io tenant, in order to find examples in order to reference. And so, I thought I might do this right now to find a good example um, to demonstrate the how to compose scanning recipes together, because it's quite easy to compose regular non-scanning recipes together because recipes are stateless and the only kind of stateful thing they return is the visitor. So you can usually just call recipe.getVisitor to get its visitor, and then you're off to the races. But it is not so simple with a scanning recipe. So I I guess here's just some examples of scanning recipes that you can search for and take a look at. So let's see, how should I demonstrate composing 2 scanning recipes together? There are, I guess we could just use this append to README file, uh, or we could change this append to README to make it configurable what file should be created. Uh, and then we can make a recipe that composes 2 instances of that together in order to create multiple files in one sort of recipe run. So yeah, let's make this guy configurable, and then we'll make a new recipe that has 2 instances of it to create multiple files in one go. So let's move references I'll just say to a text file. Let's call you append to text file. Let's rename this append to text file. We'll rename the test as well. Okay, and so now I'll add a configurable path. Now, we'll use readme as the example. We'll say if it ends with path, if it ends with, we'll set it to path, ends with path. Cool, and so that should be most of what we need to do to make what file is being appended to configurable. Let's run these tests again and see if I messed it up. Yep, okay, cool. So this still exists. This still exists, and or this still works after I've made that change to make the path of the text file configurable. So let's make a new scanning recipe which uses multiple instances of this. Now, if you're just doing a regular like YAML recipe, you can compose these guys together, no problem. Like you can compose scanning recipes together in a YAML recipe just like you would anything else. I don't know, so like this guy. So in here we could just say com.your.org.append to text file. Yeah, so you could have multiple instances of I don't know, have a readme.md and a readme.txt, and this works just fine. As does overriding like get recipe list to return to instances of this. So this the example I'm going to produce here is maybe a little bit contrived because what I'm going to do is produce a recipe, a new scanning recipe that is very much that just has this functionality. But in keeping it simple like that, we can focus on the inconvenience perhaps that is inherent to. We can focus on the things you have to do in order to compose multiple scanning recipes together in one. So if you're writing a recipe and you want to use, a scanning recipe as a component of that recipe, you have to manually keep track of. You have to make sure that the accumulator is supplied at every stage. So if I was to say, I don't know, make a like create multiple, append to multiple files sort of recipe. So we'll make an append to multiple recipe that'll do basically what that YAML recipe I just created did, and use our append to text file, or use multiple instances of append to text file to append the same message to two different text files. In order to do that, in order to use other scanning recipes, you need to yourself be a scanning recipe. So before I make this a recipe, I'll define its accumulator. And what I'm going to have here is two instances of append to text files accumulator. And so we'll say this one is the readme MD. And we'll say this is the readme TXT accumulator. And so now we're going to extend scanning recipe Okay, so we will overwrite those values, and we're going to move the description and accumulator to the top. And so this recipe will use our other recipe to append to both readme.md and readme.txt. Cool. So for our get initial value, maybe I'll go ahead and make this a value class. So I'll return new. Oh, did I do the same for this up here? Yeah, I'll add our Lombok annotations. So I'll return a new accumulator. And now, so I'm going to use the get initial value functions from the recipe in order to get the appropriate initial values. And so, oh yeah, we should add in just one option field here. And so we'll say message. Cool. So now you see we're supplying an accumulator that is the union, that is the sum of the accumulators of the scanning recipes that we're going to be using in here. And similarly, I am going to return a visitor, which applies the visitors of hit caps lock. And let's see, I suppose on here, so I could either, yeah, for now, I'll just new these up, but you could save these recipe instances on the accumulator, since you could save whatever you want there. Get scanner. And similarly, yeah, so you see that I'm, getting the scanners from the scanning recipes I'm using, and making sure that during the scanning phase of this recipe, which contains them, that I give their scanners a chance to see the tree we're looking at. And then similarly for the generate step, I suppose this will be a collection of source file. Array list. And we'll return this, and I'll say new sources dot add all. I'll just make you a list of source file. Yeah, it's an unchecked cast, but I'm not worried about it. Oh, cool. Add all. Okay, I'm going to do the same thing for the other one. Cool. So you can kind of see how I'm just like setting up essentially a delegation to the other, to any scanning recipes I'm using within this one. And similarly, get visitor, we'll do the same sort of thing. Do return new tree visitor, visit. Well, I guess in this case, rather than a tree visitor, we'll do a plain text visitor. And in here, yeah, we'll do the same kind of thing as before. Okay, so this is all. So this should now work, and we've made one new scanning recipe that essentially delegates to two other scanning recipes. Um, this is kind of awkward because if you do this, you have to take responsibility for any scanning recipes you use. Uh, and a common kind of mistake when using scanning recipes is they still have the regular get visitor method that doesn't take an accumulator, right? Like this isn't, it's not an error. You know, that method still exists, but this won't do what you want it to. Like if you try to visit something with the visitor that doesn't take the accumulator, you're, you know, you're in for a bad time. This won't do anything. Like the default implementation of get visitor for a scanning recipe just has some logic to essentially delegate to the version of the method that does accept an accumulator, and it looks for that on the execution context. So what this is essentially does is calls your visitor method with an empty, you know, or non-existent accumulator, which will not do what you want, right? It'll be like calling the version of this. Yeah, it'll be like calling the version of this with no accumulator whatsoever. And since it's a scanning recipe that does rely on there being something inside of that accumulator, um, you will not have what you want happen. So that's a common sort of mistake. Okay, and yeah, so this is what you have to do to compose multiple scanning recipes together. It is a bit of a pain. At some point, maybe we can think of a way to do better support for this kind of recipe composition in the framework itself. But I'm honestly not even sure what that would look like. So I guess if you have any ideas about how to improve that, you know, let me know in our community Slack. But right now, yeah, if you want to write recipes that in their implementation uses other scanning recipes, this is what you have to do. You have to manage the, you know, take the recipe you're using as an implementation detail of your recipe through the entire scanning recipe lifecycle. Yeah, and this can has bitten me before when like a recipe that did not used to be a scanning recipe became one. So there were still references to it that used the old get visitor method. And yeah, not a compilation error, just a runtime problem. So these are some of the things to be considerate of when you are working on a scanning recipe. And I think we're about out of time for now, so I think I'll leave it there on the subject of scanning recipes. But hopefully you found this to be interesting and useful.
Yes, thanks a lot. And then likely with the implementation you had, you'll want to share those scanning recipe instances, right? To make it such that the accumulator state is indeed shared, and you can
Well,
actually
I mean,
adds.
one, recipes are supposed to be stateless, right? So newing up a new copy of the recipe is, like I did in this recipe, is maybe wasteful of a couple object allocations, but is not otherwise problematic.
Even when it comes to the state that is kept in the accumulators?
Well, the accumulators pass through the whole time.
Okay.
So like it's up to the let me share my screen again so that we can discuss this briefly. So like when you're writing, let's go back to just the single scanning recipe to discuss this. So you see here that we define an accumulator class and we return that instance from get initial value. We do not keep a field on this class of type accumulator. We rely on the recipe execution framework passing us in the correct accumulator, the accumulator that we return from the get initial value step, into get scanner and into generate and into get visitor. So it would be a mistake for a number of reasons to have a field on this class or having something in here cache the value of accumulator. So that is, does that answer your question,
Yep.
Tim? Okay, cool.
No, perfect. Yep.
Yeah.
Okay.
Thanks for asking.
Yeah, thanks a lot. So I've already shared the link in chat as well, but if you want to read up a bit on these scanning recipes, then we have a page in the doc that goes, it doesn't go to this depth, but you'll at least be able to read up just a bit. And as always, you saw Sam try this out on the rewrite recipe star that we have on GitHub. And that is available from Moderne /rewrite recipe star. And I'm thinking maybe it makes sense to open a pull request with the scanning recipe that you have, because I don't think we have an example in there yet. So it could be neat for folks to have as a reference. And then, I think with that, we can wrap this up for this week. So just as a short reminder, we'll be at Dev Nexus, not next month, but close to next month. And there's a code that you can use if you want to get a discount there. And then I myself will be at DevTrans the week later to give it to our workshop on recipe development. So if you're at any of those, then come find us and have a talk. And hope to see you there. And then next week, we're going to have another edition. Next week, we're going to look at data tables and search recipes. So that is another deep dive. And of course, we'll also take you through what's new and see how many hundreds of new recipes we'll have next week. So,
yeah, hopefully it's hundreds of new recipes, but I don't think we can promise that every single week.
At some point, it's going to get hard, but we'll see. So thanks all for attending, and then see you next week. Cheers.
Cheers.